If you want to have video, Carl, if you turn on your video in the uh, Discord, I can try to put it onto the screen, and I don't know if it'll work, but
Okay, let's try that.
yeah. No, you're not just a. Okay. Right. So screen capture. Shoot. That's not what I meant to do.
If it doesn't work, it's not a big deal.
Discord. Right. Okay. Need to carefully hide all the actually important stuff on Discord so it doesn't show up in the stream. Alright, let's see if that works. Okay.
Yes.
Yeah, hi Carl.
Yeah.
Yeah, so we're actually running the grading on Discord for this contest because I don't know. I think we were originally going to use Zoom and then we just discovered Discord is like easier to use. Okay, so let's start with problem one then, because I think that's what people are already starting to talk about the problems. So I need to add Carl to education GeoGebra. Thanks for the follow into Nuke Launcher. Oh, oh shit, the crop is not permanent. Oh, that's not good. All right, one moment, please. Let me deal with it.
If you can't get my video on here, it's not that bad. It's also like 5 seconds delayed anyway, so.
I mean, I think I can. I just need to push the right buttons.
Okay.
50. Thanks to EpicXTroll3 and KNGTY1234 for the follow. Okay. So, oh, why am I so small? Technology. All right. Okay, so let's start with the. So I'm going to start with the cyclic quad. And since O is already taken for the circumcenter of ABCD, I'm going to just put the circumcenter at some random point. We'll call it S. So let's draw a circle with radius 1, center to S. So then I have 4 points, A, B, C, D. Okay, so ABCD is polygon, ABCD. And then I have like this variable point, O, which lies on the perpendicular bisector of BD, shall we say. So let's just take a point on there. And we'll look at the circle W. We'll take the circle centered at O passing through B. So then from here you get E and F, so no need to draw those. So E is the reflect. All right. GC. And F is the reflection of B across the... So there's E and F. Carl's head is blocking point B. Oh, my bad. Let me move Carl. Well,
You can make me block problem 2 instead.
yeah, that sounds good. Until I didn't prepare this ahead of time.
And now
Okay.
I have a name tag.
Nice. So EF is EF. So DO is DO, and the problem statement starts by saying assume that AC, DO, EF are concurrent. So you can see in this picture they're not, but we're like, okay, it seems like I should be able to, fudge O so that this becomes the case. But AC, DO, EF. Wait a minute. That's our. But here's something that weird that happens. All right. They meet when they're concurrent like this. So as I vary O, you're like, oh, well, since I have a degree of freedom, I expect I should be able to make this intersection point line up. And I mean, technically you can, but it only happens once when O coincides with the center of ABCD. And you're like, oh, that's not good. Like, you expect it to... Something already feels a little weird about this, because the degrees of freedom aren't really working out. You expect, there should be like one-ish point such that it's true, but it's always true here, and it doesn't seem to be true anywhere else. So for most points for most configurations of ABCD, it seems like the only unique configuration where you can actually even get the lines to concur is here. So that's not good for us. The problem, we're hoping the problem's not vacuous. So let's try to like get something to work out, right? And who else wasted 15? Yeah. To be fair, I don't really think you need a fantastic diagram to solve this problem. But the thing I want to illustrate is just how easy the problem becomes if you draw your diagrams carefully enough. So here's something different. This time I have a different quadrilateral, and rather than the intersection only being concurrent once, it's actually concurrent at all of these things. So the long story short is you get a little bit already just from trying to draw the diagram, the degrees of freedom. Like there's something a little fishy going on already. Like you're finding it's always concurrent sometimes and never concurrent the other times. So yeah, as people already figured out, the claim actually is that here, I need to actually write on them. So here's the critical claim of the problem, which I'll show you how you can get it even if you don't have a diagram to guess this, but if you have a diagram, life becomes very easy. Claim, if concurrent, then AC is perpendicular to BD. Okay, I need to move Carl again, sorry. Yeah, if you draw AC perpendicular BD the first time, things are very good. So this is also trivial to reverse engineer from the problem statement, but I kind of wanted to give that forward direction. So let's take this intersection now. Here's point G. And if you know what a McKell point is, you might recognize this picture already. AF. But if you don't, let's do it this way. So we'll let G is equal to AC. Let G be the concurrence point. Let me just say that. So small claim. I claim that DGEC is cyclic. And either you can do McKell points, or this just follows from how do you do the angle chase? You have these two circles. The best angle you have access to is angle GCD. So you look at angle GCD and you chase it to GED, which is FED, which is FBD, which is ABD equals ACD. So yeah, Mikhail points will just do it. So I'll say it this way. Either notice D is Mikhail point of GEBA for people who have read chapter 10 of my book, or if not, you can just angle chase it, it's fine. But yeah. And once you have the cyclic, what you do is like, okay, well, GDB, how do I want to do this? I'll do what the author did, which is if they're concurrent like this. So I know I want to be careful to not run myself in a circle. So if I look at this angle here, this angle BDO, this angle is like alpha, this angle here will be like 180 minus 2 alpha, because this is an isosceles triangle. So the upshot is that you get this angle here. Wait, not that angle. What am I doing? I don't want to do it this way, actually. What would happen if I let P be the point? You'll probably be fine, but like this is why you draw a diagram, right? So if you screw up like this, the graders can still figure out what you're doing. You'll probably be fine because like there's not that many points in the picture, but that'd be a lesson. This is why you draw diagrams. Yeah, okay, screw it. I'm just gonna do it the highbrow way. So angle chase. So the idea is I want to start from angle BDG. So it's this angle here, and we know this angle is equal to angle BDO, and then I chase it. So BDO is 90 minus DEB, so I guess I went down here, that's fine. Frick. Alright. So let me make sure I do this right. Yeah, basically because it's a circumcenter, you can chase this angle all the way down to here, and then you copy it down through to, did I write D? FB? GCD? GED? FED, yeah, okay, FBD, and then this is equal to ABD. So you can take that angle and you can transfer it all the way until, wait, why did I go through E? D, yeah, okay, 90 minus this, dB. I'm just running myself. Basically, my point is you take this little angle through and you chase it through alpha, and you can eventually get back up to this place where you have angle DGC. And what you'll find is that because of the circumcenter, you end up with this 90 degree. What would happen if I accidentally put E on AB and F on BC? They're probably fine.
As long as it's clear what you're doing, that E on AB and F on BC is not an issue. Configuration issues might be more problematic, but
yeah. But
I think as long as you can fix configuration issues by just using directed angles, you are probably fine.
So that shows that we have the 90 degrees. So what's happening is that in fact the angle condition is just the the concurrence is just saying that these two guys are perpendicular, which I guess I freehanded this diagram so they're slightly off, but let me just make them actually grid lines. Good enough. Okay, so that's like half the problem. The other half of the problem is involving the orthocenter H. And this is kind of just there as decoration, because if I know the angles, once I have this, I know the angles, what am I trying to say? Okay, here's the orthocenter, whatever. No. Zero guaranteed. I mean, I think a lot of the point of the USEMO is for people to get zeros, because that's usually what happens the first time you take a 4.5 hour 3 test. And it's better if that happens on this than on the actual one. Like this is basically a practice USOMO at this point, because now we know there's actually a USOMO. So USEMO is mock USOMO. Um, yeah. So anyways, what was I saying? You can just kind of copy the angles now. So the orthocenter here means that the angle HEF you can just compute, because that angle to finish. Okay, I'm out of screen of state. So I'm gonna hide this. Okay, cool. It barely shows up. Yeah, basically HEF is like 90° minus these things, and because I have the cyclic quads, I can kind of just copy the angles everywhere and find that the perpendicular thing translates to the perpendicular there. Yeah. Can we just spiral similarity and win? Yes. So the highbrow way to think about this is that because of the McKell point, DEF is spirally similar to DAC. Because of the angle chase, you know this is a right angle. So why is the orthocenter of ABC relevant? Or sorry, DE-ref relevant? The orthocenter of ACD will be the reflection of B across line AC. So for the people that know spiral similarity, what's going on is if I take triangle center ADC4, the orthocenter of DAC. Let me draw it this way. KAC. No, need a 4 there. Because the quadrilateral has perpendicular diagonals, you probably know that when I reflect the orthocenter, that means that I actually just reflect the point D across this side. So, you get this picture where B is the reflection. By spiral similarity, it's similar to this blue triangle. So since the yellow and blue triangles are similar, that will do it. And that's sort of how I came up with the idea to add the orthocenter, but you don't really need it for actually solving the problem. How hard was USEMO compared to USAMO? I think this problem is about an MO14 level geometry problem. I think 2 is actually hard. Like even if you have the right idea, it takes a while to execute. Mouse greater than IMO. Maybe.
IMO has a lot of variance.
Yeah, I think all the contests have a lot of variance these days now, actually. USEMO is a little more stable than it was. Like back in around 2010, there was lots of stuff. Okay. Any other questions about this problem before I go on?
Another fun note about this is that once you get the spiral similarity, it becomes not a very bad complex bash. if you are bad at angle chasing, like I am, you can just sort of pick one of your circles, define your spiral similarity by a complex number, and then calculate and win. It's fun.
Oh, jeez. Thanks, don't drink and derive, bro, for the follow. For Steven, if you want the problems, they're posted in HSO. I will... Actually, that's a good idea for the command. I'll make a problems command. Run problems on. Submit. Yeah. I mean, also Spiral Sim is a big part of the problem anyways. Yeah, so whether the configuration issues will dock points is basically up to the rubric. And a lot of things are just up to the rubric in general. I think for Math Olympiads, the graders all agree on what the solutions contain. They just don't necessarily agree on how many points that should be worth. So it doesn't really matter from a student perspective because, I mean, you just try to not make mistakes. But then when you make mistakes, you get the fun, you get the fun situation of like, oh no, I don't know how many points I'm going to lose. Because then it's just kind of like, well, something. Can you bypass AC per BD with DODH isogonal? Maybe. I do you get any points off or not? No. Where USEMO will not dock you for bad diagrams even though we want to. This is JMO1. I think this is harder than JMO1 level. I think there's a little to do. Like you need to figure out what's going on. Will we lose points for not directing angles? It's up to the graders. I would guess no. The tradition very often is that rubrics will just say don't worry about configuration issues. You see this at RMM all the time, for example. But it's not always the case. For example, in IMO 2019, sixes rained from the sky on problem 2 because they actually started docking points for people who didn't mention radical axi could be parallel rather than concurrent. What is your research about? I don't do research yet. I'm still in my take classes stage of school. What if you use directed angles but messed them up? I mean, if it's a typo, it's fine. If it's an actual... If you're just off by signs, it might be okay. All right, let's go on to problem 2. Oh my god. Yeah, so this one is Carl's problem. Well, I'm gonna tell you how I solve problem 2, but it's not gonna be what I expect people to do. No. These hotkeys are taking me so long to get used to. Window capture, Carl. You have enough V-Bucks to make a poll? What do you want to poll people on? Alright, so let me scroll past this. The math here is from yesterday's stream. Because I want to. Yeah, so I think one part of... There's a couple of things about this problem. One is that the solution set is usually bigger than you expected. And this is why for not just problems like this, but functional equations in general. Thanks TRDJ Dumplin for the cheer. You want to actually spend some time not even trying to solve a problem, but just making sure you have not missed any solutions. I tell my students that for a standard RFE, at some point you always want to plug in mx plus b. Make sure that you didn't accidentally miss any linear solutions, because like if x plus 1 is the solution and you don't notice, then RIP. R to R functional equation, so like a real valued. Here, like, okay, you have the identity, but in addition to the identity, you can scale, right? So theta of p is equal to 2p is also a solution, for example. But also, what other things can I do? I don't have to multiply on by just a constant. I can multiply on by, for example, x squared plus 1, right? And this would also just be fine, because if I multiply on the constant, none of the integer roots change. What other stuff can I do? Well, I can shift, right? So what I mean by this is you take p and instead of x, you plug in x plus 5 or something like this. And this will still work because it's like you shift the integer roots by -5. And yeah, someone has the last one. Negating x is also just fine. So like it's hard to notice this because in part because you're trying to solve a problem at the same time you're trying to guess the solutions, which is why I say, like, if you can, like, just take a moment and spend like 5 minutes trying to do nothing but just find solutions. Forget like trying to actually solve it. Just make sure you don't miss anything, because this is a problem where, as you can see, it's very easy to miss stuff. On the other hand, none of these solutions are actually hard to check once you notice them. It's just like, oh, this is a thing that could happen in the problem. Okay, so that's the bit about... Yeah, I saw the shifts. I missed the multiplication by x squared plus 1. I somehow, I didn't write it up carefully, which is a big thing, which is a lot of the reason I missed it, but I initially just thought multiply by constants and then shift. Which is why, again, like, part of the reason you should write up your solutions well in the contest is because it helps you check your work. Okay, so let me explain my thought process on this problem. This is one of the few problems I actually got to do with no spoilers. There was a long packet. So, how many points would I get for guessing the solution set? I think you'll probably get something for solution set. I don't know how much. That's up to the captain. So the first thing I want to kind of think about, let me do a very simple case first, which is we're going to look at, well, theta 1 can be like anything, right? Theta 1 can be whatever it wants. And actually, we think everything will be a multiple of theta 1. So this theta will be very important because it's the multiplier. So let's give it a name already. We're going to call it r of x. So by 1, I mean this is the constant polynomial. So it has no zeros. Okay, so if I want to get... sorry, I should say has no integer roots. Let's be more precise. So if I want to get at x, the next thing I naturally want to go over is the polynomial, just what is theta of x. And the way I can look at that is I look at this ax plus b. If this is going to be equal to a times something, we'll call it f, whatever theta of x is equal to, and then plus b. And so what can we say about this? Well, we have a statement that's very strong.
R of x, right?
Sorry, yes, b times r of x. Thanks. So we have a statement that's real strong. It's like, okay, left-hand side is an integer root if and only if the right-hand side does. And you use that in a different way than you might initially think. You say something like, okay, well, that means if I plug in x equals 1, for example, that tells me that, for any a and b such that the ratio is f of 1 to r of 1, then you get a to b. So let me actually say what the statement is, because it looks so different once I actually write it. Claim, so conveniently r of x doesn't have a root. That will make my life actually a lot easier. f of x over r of x takes on exactly the integers. Let me phrase it this way. Takes on -2, -1, 0, 1, 2 as x ranges across the integers. So the statement in the problem is actually very strong. It's like I have this thing which is a quotient of two polynomials. I note the range exactly of this f over r. And what do I hope? I want this to be like, according to the answer we have, we hope it's like we hope it's a linear polynomial. And if it's a linear polynomial, it better have slope plus minus 1. So in fact, I claim I can prove this outright. So the first thing I want to do is like, okay, look at this. Like, am I worried that it could not reduce? So the answer is no. Claim f of x over r of x is actually legitimately a polynomial. For now, it could have rational coefficients, but whatever. I claim it's at least a polynomial, so there's no stuff in the denominator. And the reason is that if it has a denominator that doesn't reduce, well, when I do the division algorithm, you get like some polynomial, and then you get the denominator and like the numerator. So this has smaller degree, and we're saying this has positive degree. When will APMO solutions come out? I have no idea. And I claim this is bad. I claim that this will just not even give you integer values after a while. Because, well, what happens is you take x big. When I take x to be a something large, let me do this in different color. What happens here? This is like, so this has some particular denominator. So this is going to like it'll just be some integer with some denominator not too big, like bounded by the denominator of the coefficients of that thing. What happens here? It goes to 0, but it's not equal to 0. And so this is bad because like you have a little, you have some bounded denominator and then like this little dust, like this tiny little displacement. And this displacement will cause it to not be an integer. So what I've shown really, I'll actually write this out because it's a separate claim of interest lemma. If f over g is a quotient, let's say rational functions which aren't polynomials can't take integer values forever. Basically, I'm claiming this fraction has to reduce because otherwise you look at the little fractional parts and you get this little dust that will kill you off. Okay, so it's a polynomial, and it's a polynomial that it could have rational coefficients, but it's taking exactly the integer values. So what happens with that? If the polynomial is degree greater than 1, you're going to run into density problems. Like the polynomial will grow too fast for you to hit all integers. So it ought to be linear, and so it has to be plus minus x plus c. Once you have that it's linear, then it's easy to actually do math by hand. So for this case, You conclude the degree is 1 for density reasons. And thus should be, once it's linear, it's easy to handle. It's concrete enough that you can just kind of run it over. Fine. So that shows you that theta of x is what we think it is. It's the constant thing, or sorry, it's the multiplier times plus minus x plus c. Any questions up to here? Bro, half the people here wouldn't have known. What? Wait, do people like not know division algorithm or something? Hi, Caliph Wynick. Oh, I wasn't talking to you. Oh, I see. You're complaining. Okay, whatever. Yeah. Okay. Sorry, I misinterpreted something in the Twitch chat. People were flaming each other and they thought they were talking to me. Um, why do they have to take on all integers? So what's happening is, you look at the condition. The condition is that this in this box, right hand side has integer root if and only the left hand side has an integer root. So for example, if I want the quotient to take on the value 2, I put in like x minus 2. I think that'll do it. Did I flip this side? No, that's fine. X minus 2. And conversely, it can't take on non-integer values because the other way around. Why is theta ax plus b equals afx plus brx? Because you're given that theta is additive. Division algorithm doesn't imply it's an integer polynomial. This is actually a stumbling point, because here x times x plus 1 over 2 is an example of a rational coefficient polynomial that actually still takes integer values everywhere. Why does the coefficient of b depend on x? We can pick a and b to be whatever we want. So this statement is true for all a and b, and the problem condition tells us that integer root if and only if blah blah blah. So this is a complete proof that theta of x does what we want it to. Ooh. How many points would I lose? That is up to the graders. Anytime you make a mistake, it's just up to the graders. Like I make no claims that the beliefs of graders are consistent. I just claim that they correctly understand that you made a mistake. How are we sure the dust argument works? I'm not sure what that means. So I can spell out the details. So because this is a quotient of things where the denominator has larger degree than the polynomial, this thing can get arbitrarily small just because the limit goes to 0 as x goes to infinity. On the other hand, the thing on the left, the polynomial in Q of x, it is like a concrete polynomial. It might be like, for example, x plus 1 over 3. Let me give examples. So for example, this thing could be like x plus 1 over 3, and this thing could be, I don't know, 1 plus x over x to the 8 times 3 or something. And so the right-hand side will go to 0. The left-hand side, you look at it and I'm like, oh, the fractional parts will be multiples of 1/3. And then I'm adding this little displacement. It definitely won't be an integer. Hey, there's no ad break. Did someone redeem the ad break? Oh my god. We'll do it after problem 2. Okay, any other questions about this? Okay, so that's how you can get theta of x. The next thing I'm going to do is I'm going to go after theta of x squared, and you'll see how to do any from there. So we have r of x was defined as theta 1. And again, let's look at theta. Now ax squared plus bx is a of theta times x squared. Well, I'll call that f. That's the thing we're going after. And again, right-hand side has an integer root if only left-hand side does. So the left-hand side has an integer root when minus b over a is a square. And the right-hand side, minus b over a. And I forgot the rx again because I keep just forgetting it. So the same claim applies, except this time it's squares. So claim f of x over r of x takes on exactly 0 squared, 1 squared, 2 squared, dot, dot, dot. So same thing I did before. Actually, I shouldn't scroll all the way up. I'll zoom a little up. So it's like this, except this time it's the squares instead of the normal numbers. And so same proof implies, f of x over r of x is actually a polynomial g. But this time it's a little more annoying because I can't just say it should be degree 2 for density reasons. Well, I actually can, but even then, you have to fuss a little bit. However, let's step back and think about this. What do I have is I have a polynomial whose values are the perfect squares. And, that's a little suspicious, right? It's like, if I tell you, I gave you a polynomial and its range is perfect squares, you're like, well, is it really not a square? And if any of you did USMCA, you might remember there was recently a problem. 2019. Thanks to Super Nito 10 for the follow. USMCA 6 was a problem that said P is a polynomial with integer coefficients. If n is a perfect power, then P of n is. Show P is either the identity or a perfect power. You might have recently done this problem. If not, I won't say too much, I guess. Let me decide what I want to say. And in fact, if you take any proof of the USMCA problem, you ought to be able to prove the following theorem. Theorem, if I have a polynomial, let's say g of x, with integer coefficients, thanks to Ttrong1000, Joe for Sarun061729, and KVS34 for the follow. If g of x is always an nth power for all x, then g of x is equal to some polynomial to the n. No, we're not doing 2017 G6. And if you don't know the proof of this problem, I'm probably not going to do it here because it's going to take too much time. The basic idea is that you can control the VPs of the individual irreducible factors of G. That's a very short version. But this is a folklore problem that I had happened to see like 3 weeks ago because I was test solving USMCA. So then I was like, oh, well, that's very convenient because here I have a polynomial who's only taking on squares. And so what that means is this polynomial g, by the purple claim, actually should be a square too. And so g of x, what does that mean? It takes on... It's a little annoying because squares drop this sign. But g of x has a square root. And it takes on 0, 1, 2, dot, dot, dot. It just takes on all the integers except with plus minus signs. What I mean by this is it's possible g could take on like -1 and all +1. F of x over r of x can't take on 2 because when I look here, right? So what happens if it takes on 2? I let a equals 1 and, a equals 2 and b equals -1. No, sorry, 1 and -2. And then you get x squared minus 2, which doesn't have an integer root. So my point is this statement about if and only if integer roots, actually, it looks like it's about polynomial roots. It really isn't. It's really about, I would say... Oh, what happened to Carl's video? Carl!
Here, give me a second.
No problem. Okay, let me just keep it. Yeah, he'll be back, I think. So, yeah, it's sort of saying something about like the range of polynomials is doing what you expect. Anyways, now that I have a polynomial square who is taking on like at least half the integers. Again, by density, it's linear. And again, once you know it's linear, it's very easy. You know, it ought to be plus minus x plus c. So we successfully proved that x to the n does exactly what we wanted to do. Theta of x to the n will be plus minus x plus a constant times your r of x. So at this point, so theta of x is like r of x, n, plus minus x plus your constant times n. And that's basically what we wanted to prove. Like once I use this thing that a polynomial always taking squares is actually legitimately a square, that tells us theta of x to the n behaves the way I want it to. Unfortunately, we're not done yet because there's this thing called the pointwise trap. And it's not happy. If you have a pointwise trap, what's happening is you don't know the choice of constants and signs across the different values of n are different, or they could be different from each other as n varies, because the c might depend on n. So you kind of just have to run it over manually. You can do this because it's now concrete enough that you can just write stuff. Do you guys want me to do the pointwise trap? Do you want me to handle this or just sweep it under the rug? Okay, I'll show you how to deal with the pointwise trap. So first I'm going to show the constant has to be the same. So let's look at theta of a of x to the, here, let me do this. So we're going to say, without loss of generality, theta of x is x by shifting, reflecting, and dividing by 1 over r of x. So you strip out the r of x that's everywhere, you shift it so that x is centered at 0, and then you negate it if you need to. Thanks, YRI1220 for the cheer. So because of that, we have theta of x equals x, and then let's, in the pointwise trap, we're always looking at x to the n, right? So let's say theta, this one's doing something different. So here's x plus minus x plus some random constant to the nth plus b times x. And what I want is I want c to be 0, and I want the sign to be plus. Okay, let's go after the c equals 0 first. If c is not 0, then, well, left-hand side always has a root. So the right-hand side is always supposed to have a root, no matter what a and b I pick. So x plus c to the n all over x should, again, take on all integers. Take on every possible integer value. If c is not 0. Because if c is not 0, then you can divide out by the x. And that's not going to happen for n greater than 2, just for density reasons. And for n equals 2, you expand the quadratic, and you're like, well, you're dividing by some... Wait a minute. Yeah. So n greater than 2, density doesn't work out. N equals 2, I can expand it. I'll get x plus 2c. I feel like I'm confusing something. There's just no way, right? Am I crazy? Oh my god. You guys want an SL17G6 emote? That's so bad. Okay, what's a proof this does not take on every possible integer value? I mean, I feel like that's not the right thing to say. I should say it has an integer root for every a and b. And it doesn't because I can look at the discriminant. Okay, what's the discriminant of this? It's, oh, Jesus. Why do you guys kids make me do this? Let me check my notes. What did I do the first time around? Yeah. I mean, okay. It's not true for dense. Actually, you don't even need to do density reasons, right? You just look at it and it's like, you can use the dust argument, I think is easier. You have like x plus 2. Like, it doesn't even take integer values for most x because you have a quotient. So forget density. Like, usually not even an integer. You can't even get infinitely many integers. So that's half the pointwise trap. It tells you that the c should be 0. So we're halfway done with the pointwise trap. The last thing we have to do is like get rid of the sign issues. And to deal with the sign issues, I think you just need to look at x to the n plus x minus 2, which is plus minus x to the n plus x minus 2. So this sign had better be plus, because otherwise it doesn't have an integer root. I wrote BS, is that the same as fake solving? Depends on who you ask. I think fake solve, usually when I hear it, it means someone thought they solved the problem and didn't. If you deliberately write BS, I don't think that I usually call it fake solving. What's a solution set? It's things that look like this. Generically, you take any fixed polynomial you can multiply on. You can have a shift, and you can have a plus minus reflection. That's a solution set.
All right, so
Mhm.
Evan, are you done with your solution?
Yeah.
Okay. So this probably won't be very clear because I can't write things, but I want to talk about a solution that I had that was rather different from this solution. So the first claim is given if we have two polynomials p and q and they're integer polynomials. Evan, would it be possible to write this down?
Yeah. Let me. Do you want me to write on board or type it? Which one do you think?
Typing is probably best for this claim.
Okay. Let me set up this then. All right. One moment. One moment, please. Thanks, Imani Vibes, for the follow. There we go. Okay. All right, Carl, go ahead.
Okay, so the claim is that if we have two polynomials p and q with integer coefficients, and p plus nq has an integer root for all integers n, then either p and q share an integer root, or p of x is a linear polynomial times q of x, essentially.
Equals.
So the motivation from this claim basically comes from looking at what your function can be on degree 0 and degree 1 polynomials. So it's sort of a similar thing to what Evan did at the beginning, but it applies in a more general setting. The proof is moderately interesting. We start with looking at p of 0 and q of 0, and then if we let kn be the integer root, of this polynomial with n, then kn divides some linear function of n.
Kn divides a plus bn, right? Okay.
Yep. This kind of intuitively, this should imply that kn, because kn should have some sort of quote-unquote nice structure, this should imply that kn is either constant, in which case p and q share an integer root, or kn is some linear function in n, which gives you the second case. The proof that I have talks about the greatest common divisor of a and b, and then uses Dirichlet's theorem on arithmetic progressions to find a bunch of primes where you're then forced to be a divisor of either a constant thing or b, a linear thing.
Yeah.
There are probably ways around it. At least I hope there are ways around it, because using Dirichlet is not very nice. RE pronunciation, it's technically German, but from a city in Belgium or something. You can kind of pronounce it however you want. No one will get mad at you. So once you have this, you basically just run around and apply it to different things. The structure and casework ends up being pretty similar to how Evan's solution looked.
Yeah. I will say I actually had to use Dirichlet as well, but it was embedded in the proof of the USMCA problem. Like basically what you do is you use Dirichlet to find a prime for which you can force VP of f of thing to be 1. Yeah.
So I suspect that there are many different solutions that involve this same sort of structure of try to understand small degrees and then generalize to large degrees and then fix up the pointwise stuff later.
Yeah, the pointwise is the real. I think everything just ends up with a pointwise thing.
Yeah.
Okay, any other questions on this? Mo's rating for this. How hard do you think this is, Carl?
What is Mo's rating? I'm not familiar with the scale.
Don't worry about my scale. I can convert whatever you say.
Okay. So when I originally wrote this problem, I thought it was more a 1-4 level problem. Then I kind of wrote my solution up, looked at it, and decided maybe I was a bit mistaken. So, I think it's a lot of the difficulty in this problem lies in that it's easy to get stuck doing something wrong and either not knowing it or knowing it but not being able to fix it in a reasonable way. So I think this is depending on how you think about problems, I think this could be anywhere from an easy-ish 2-5 to a hard 2-5. I also think generally 2-5 is the area of problems that has most variation in difficulty. So, I don't know. To me, it feels like a reasonable 2-5.
Yeah, I think my impression of the problem is I think the I don't think I had to use any serious tricks when there wasn't a big idea I had other than quoting the USMCA problem, which is something that I've seen like the weaker versions. The USMCA version is like the strongest version of the problem I've seen, where it's just n is a perfect power implies p of n is a perfect power. Usually you see a formulation like p of x is a kth power for every integer x. But it's sort of like I would say it was a problem that favors experience a lot because you don't need to come up with a super tricky idea so much as need to just know what you're doing and not make mistakes. Identity this problem is extremely easy to make mistakes on because the solution set is so much bigger than you initially guess. Why isn't Google Sheets working for me? I don't know.
Also, to answer Learner 102's question, the two kind of broad ways to write problems are you come up with an idea that would be nice to put in a problem, and then you figure out a way to put it in a problem. And the other one is you come up with a statement that looks nice and try to solve it. The ideas in this problem I don't think are very interesting. So the problem was written in the second way. I just said, okay, additive functions on the set of polynomials seem to be pretty nice. We saw that in a TSTST 2018 problem, I want to say.
Yes, it was mine. We used the same notation on purpose.
Yes, so you have the harkening back to the notation, but there are interesting things you can do, and the question is basically what kinds of structure can you preserve with such maps? And so this is just having an integer root is an interesting example of structure. So that is how I came up with the problem.
Yeah. Yeah, I figured this was probably you started with this statement as well. Is there a USEMO tag? Maybe can I tag these 3 problems on IELTS as USEMO so I can find them more easily? Okay, I should edit Nightbot to use the tag as well. That's actually a lot easier. How many ads have happened? So far only 1 ad request, which I guess since I'm messing with AOPS, now would be a good time to honor it. So we're going to take a quick 30-second ad break. Stick around, mute the thing because it's probably really annoying. Thanks for supporting this stream and giving me like 5 cents of ad revenue. Okay. I should have seen that coming, that there people were going to. Yeah, this is a tough. Oh, there's a second request. I didn't even see it. Why is everyone redeeming ad breaks? I don't understand. Well, I'll honor the second request after problem 3. I don't want to. The stream is a little more official than usual because it's like not just me horsing around on shortlist. It's like attached to a contest, and I don't want to appear that I don't know. Honestly, it's a little weird that I run ads at all, but I thought it would be funny. Okay, so problem 3. So problem 3, I actually did not get any time to work on it at all. So I'm just gonna tell you the solution that Nikolai sent me. As far as I know, did anyone actually get this? I don't see any solutions on AOPS yet. Can I link the link? Oh, geez, people don't even know what the answer is. Okay, so that's how you know the problem is hard. Uh, okay. Why? What is my compiler doing? Okay, well, we can... Now I'm curious. So I'm gonna make a new poll. Yes or no? Yes, no. If people haven't confirmed what the answer is yet, here's your... We can find out how good we are at guessing. When will scores come out? I think June. We're hoping for mid-June, but I have no idea how well this is gonna work. I think this is the first time that anyone's run grading this large online, because usually USEMO grading is in person, and we don't have a good sense of how efficient the online one will be. Yeah, 2020 is random. It doesn't really matter. I will say the reason Nikolai's name was in the problem, it wasn't there originally, but I thought it was too hard to understand as written because of the order of the quantifiers, so I wanted to make it look like a sort of two-player game so people could understand what order the quantifiers came in. Oh wow, I can vote on my own poll? I did not know that. It seems no way to do that though. What if your name is Nikolai? Oh no, I apologize. Alright. Okay, good job. The answer is actually yes. Guessing extremely overpowered. Shoot. No, wrong button. Alright. One moment, please. I need to dig out. So, as I said, I didn't actually get to work on this problem, so this will just kind of come out of thin air. Thanks, Grizzy Problem, for the follow. Problem solver 79C. So, here's the first thing I'm going to do. I'm going to ignore the bit about the polygon and just pretend that I have like a just generic set. And then later I'll fix up the thing. So here's what I'm going to do. I'm going to start with a construction that works but has holes. Alright, let's hope this works. It's a little too big actually. Okay, so this is a polygon that I guess it used to be a square, and then I've like really punched a ton of holes into it. Is a Menger-Spung legal? It is not. It's not. This is not a polygon because there are holes. Construction. So to clarify, you're actually not allowed to have holes. We'll fix the holes later. I mean, yeah, polygons don't have holes. Is that not clear? I mean,
it's encoded in the definition of the word simple, I think.
I see. It sounded like they were allowed. Okay, I mean, this is why the English Language Committee has a very hard job. Yeah. Yeah, simple polygons definitely don't have holes. I actually looked that up. I just figured that no one would think polygons had holes, so I didn't clarify it. But apparently that was a mistake. Okay, but we're going to first do this and say we'll use this sponge shape with 3 replaced by n at least 3, the number of iterations, and m at least 3 odd, the... Let's do n at least 1. So here I did 3 and... This is 3 and... This is 3 iterations, okay. The number of... how do I say this? The scaling factor, that's better. So you can imagine the sponge, except instead of thirds twice, I do like mth parts. So I cut out the center 1 over m and repeat, and then iterate this n times. So call this f, and we'll say a standard copy of f is one centered at a green cell. So, you know, I have a green tiling, and I assume that, you know, something there. Every copy of f contains at least 1 green cell. Well, by symmetry, because I picked a symmetric, it's actually much easier to think about this way. I have a tiling of the plane with overlaps by f's. So standard copies cover the plane by definition. That's how you think about it. It's like I have this f, and then I place a bunch of copies of f such that they cover the entire plane. And then what I want is I want to show that there's some point covered a bunch of times. I think that's actually the first big insight, is that the green, if you think about it in green cells, I think you go crazy quickly. But if you think about it in terms of tiling with the f, it's much easier. It's like I have a tiling, and I want to make sure you have a tiling, you want every cell to be covered, and you want not too much overlap on any cell. Well, I claim you can't do that. And what happens is start at any cell. Start at any cell, which is the standard. Do I want? Yeah, actually, just start with any cell. It's covered. You don't have 20. How does not overlap? Yeah. So when I say not, you want it to not overlap too much. So what I mean is Nikolai is challenging you to cover the plane with copies of this guy. So everything's covered, but nothing's covered more than 20 times. Does it make sense? And the centers of the tiles correspond to the green cells. What pattern does the drawing follow? You delete m to the minus 2i from for I equals 1 to ... n. Yeah, so we're not going to use the congruence or rotation at all. I picked essentially symmetric examples specifically so that even if you fill in the holes, but it'd still be a rectangle, you can fill in the holes, but then it won't work. You need the holes to show that this example works. So anyways, is everyone okay with this translation? What I've done is I've said, rather than imagining I pick green cells and then the polygons moving around, tile the plane with polygons centered at the green cells, then, you know, bumble around. What's the motivation for using the holes? Yes, I'm centering f at the green. yes. So that's what I mean by standard copy. A standard copy of F is 1 cm cell. Why are we using holes? Because what I'm going to do now is you start with any cell. It's covered by some standard guy. We'll call it F1. This is worse than 2017 G6? No, it's not. 17 G6 is just bad. Carl's laughing because he actually knows what that problem is.
Very, very few things are worse than 2017 SLG6.
Okay, what was I trying to do? Sorry, let me do this. So I'm going to take any square C with same dimensions as F. And I'm going to start with its center. It's covered by some F1, so there's some standard F which covers the center. And you go to a degree 1 hole in C of F1 and take its center. Aren't there holes at the center of F? I'm not sure what you mean by that.
The center of F is not covered in F.
Yes, that's correct.
It is not a cell of F.
That's correct. It's covered by some standard F1. So again, well, here's the thing. I'm imagining I have a tiling. I'm taking a cell. It's covered by some F1. Then I think we're asking if the middle 1/3 by 1/3 should be white. Am I crazy? I don't think so. I think Nikolai wants it to not be white. Oh, did I mess up the picture? No, I don't think I did. I think it's important that there's like... The scaling factors are by 2. Like the normal sponge is... The sponge you're used to is that each hole has 1/3 of the previous one, but this time the hole has 1/9. And the reason you want 1/9 is because you want this thing where... Actually, the 1/3 one might work as well. I'm not sure. Let me roll around with this and I'll see if I can get it to work for a normal sponge. But I think I want this one. So your F1's covered by some standard thing, and you go to a degree 1 hole, C1. You take its center. That center is covered by some other F2. Go to a different hole in C, and so on. So my point is, you start with an F1, you go to a hole, you take the standard copy covering it, go on in. And the upshot is that if you keep following the holes, jumping into the holes within the cell C, what this means is that you eventually manage to squeeze out n disjoint, or not disjoint, n different standard cells with near C. So the point of this whole construction is that in a small area, like in a pretty dense area, I can keep jumping through the holes to find that there's a bunch of tiles. Now, how big are the tiles? Okay, I actually needed more space. I'm gonna run out of space. Oh no, that might be too small. Okay, that's good enough. Okay, so in a 3a by 3a square, we can find n standard copies of F, where I fixed m and n. So m and n don't change, they're fixed numbers. Yeah, thanks to Bitter JPEG for the follow. But how many cells are in F? F has a squared times 1 minus 1 over m squared, the density to the nth number of iterations. Wait, I really think the number of iterations in Nikolai's notes is off by F. factor of something. I think there's an index here. Let me double check this. Oh, okay, he's doing something a little different. That's fine. So yeah, this goes n minus 1 times. N is 1 more than the number of iterations for him. So yeah, this is very confusing because I started by throwing a sponge at you, and that's like not a way you usually want to start a presentation, but it happened. But my point is like if you think about the problem in terms of I have a thing that covers the plane, but you want not too many, then the sponge means that I can keep jumping. Thanks WJ121 for the follow. So this is the area. And n times the area of f can be made to be greater than 2020 times n9a squared. If I make the sponge sufficiently not dense... What a terrible highlight. So you can choose m and n such that this happens. So what I've done is you rig up your m and n such that the sponge is pretty dense. The holes are very small, but the holes go very deep. And if you fudge the parameters correctly, you can eventually get that you think like the sponge almost has the same area as the square, but there's n of them, and so this causes some cell to be covered more than 20 times by pigeonhole. Man, people are really abusing this highlight feature.
Please don't spam. Thank you.
Carl, you have the timeout button.
Yes, but I don't know where it is.
Oh, rip. Okay, well, I have a timeout button.
Okay.
Okay, so that is actually literally a complete proof that this example works if you allow the holes. Because what it's saying is you use the sponge to force out lots of copies of the polygon that still have about the same area. And when you do that, you get a really thick covering, which is what you want. So now I need to fix the holes. But that's actually pretty easy. What you do is dilate by some large factor d, and then cut. Nikolai called them canals, but basically what you do is if you have a polygon that has a hole, you can cut a little path from the edge of the polygon to the hole so that it becomes a polygon again. Yeah, so you dilate by a bunch and then you cut little, like very thin incisions into it to make it into an actual polygon. If you dilate by something that's large enough, this won't affect the density because the density affected is proportional to like 1 over d and you can make d big. So you're fine. And that does it. That is a complete solution. Alright. There's no way that the actual yeah, so the polygon stops being centrally symmetric after that. I don't get how jumping works. It's really hard to explain without, like, scissors, honestly. But basically what happens is, like, here, let me see if I can use a cursor. Pretend you have some cell, okay? Like, let's say the cell's here. It's covered by this big blue guy. So you go and you look, like, okay, well, in here, there's a cell, so I'll take this center cell. And it should be covered by something, so it's covered by some other translate. And then you jump into a little cell, say, okay, well, take another tiny cell, it's also covered. The reason we need this complicated hole structure is to ensure that as we're doing the jumping, we kind of stay inside a fixed a by a square. Like the cells we're moving in the path stay inside an a by a square so that your density argument here will be okay, where you only have a factor of 9, which you can, 20 times 9. Yeah, the jumping is very confusing. You have to actually, I think you have to like sit down and think about it for a while. I don't know how much me saying it here will help. Does USEMO follow the Jeff rule where 4 easiest problems are different subjects? No comment. You'll find out tomorrow. I will say there isn't an official policy of this shape. Like, I don't require this because I think it's too constraining, but it is certainly a desirable property. So, it could be, is what I'm trying to say. Can you put some inequalities, please? Well, I already finished picking the problem, so no. Any other questions about this? Do you count P2 as NT or ALG? I think there's a lot of... I think, in hindsight, I think it's more number theoretic than I originally thought. Well, most difficulty was P3. I can't judge this because I literally had no chance to work on the problem. I think based on what I'm seeing on AOPS, which is that no one is really claiming a solution, that probably means it's at least 45. Usually if it's anything less than 45, like people will post the solutions pretty quickly. Actually, let me stake that claim. I checked a while ago.
Still nothing.
Yeah, still no one posted.
And with respect to problem 2, strict subject classifications are, I think, becoming less and less important. So there are some problems that are genuinely half of one subject and half of another. And I think this one falls in, this one would be categorized as roughly half number theory and half algebra. I think it does have some of both.
Yeah, actually, what did I categorize? In the internal report, I forget what weights I put.
Did half and half.
I did half and half? Okay, that sounds like the right thing to do. When will APFMO be graded? Not my contest.
We should probably grade that at some point.
Wait, Asian Pacific. What's APFMO?
It is the April Fool's Math Olympiad. It's a bunch of terrible problems.
I see. I just read Nikolai and Noob. Yeah, I'm a little... I feel like I think me putting Nikolai's name in this problem might have decreased the solve rate because people are so scared of Nikolai now.
I think when people saw that there was a combo problem at the 3-6 level that involved a grid, I don't think it's too hard to figure out who wrote this problem.
I don't think that pattern is that strong. Like,
it's pretty strong.
Is it? Okay. Let me see. No one puts their name in their problems. Well, yes, but Evan contests get a lot of Evan editing, so names just kind of appear. Will any of these problems show up in Otis units? Problem 2 definitely will. Problem 3 might, but I don't know. Problem 3 might be something that ends up in C8 Summit, honestly. It has that feeling of just like killer combo. P1, I don't know if I'll probably add it to LMGO, but shrug. But yeah, this was not a gentle day, just for the record. Like, 2 is... I don't think 2 is a 3-6, but I think it's close. It could be a 3-6, maybe, but I feel like it's closer to 2, but it's like... pretty...
It is a 3-6 time investment.
Yeah, problem 2 takes a while. That's for sure. Carl's back. It's because
Hello.
I don't have his over. I have to like manually add his face to like every overlay. I didn't set up a global thing.
Sorry about that.
That's fine. Evan.
Oh no.
Oh no. Well, okay. I'm going to quickly. I think I have another ad break to honor, so I am gonna take a quick ad break, and then after that, if people still want to stick around and horse around, we can do that. Can I use 1v1? What's an ad break? It's when ads show up on the screen. I don't know if they're actually showing up. $380 of watching Evan. Yeah, the V-Bucks.
Oh dear.
And streaming so. Alright, cool.